Good afternoon, good morning, depending on which time you're signing in and watching this lesson. This is going to kind of include Tuesday, January 19th assignment and Wednesday, January 20th. So we're going to have two things going on here. Remember, we were out on Tuesday, January 19th and Wednesday, January 20th. We were out on Monday for MLK Day. A couple of announcements to make. Please remember that this week is the end of second quarter, so you only have until Friday, January 22nd, to finish making up any missed assignments or any work that you might need. So all tests and quizzes need to be updated by the end of the day on Friday, January 22nd. That's the last day. We will have our last major grade on Thursday, January 21st. And I've been reminding everyone of this. So if you've been in class with me up to this point, I've been telling you about it. I've been telling virtual students. So Thursday, January 21st is our last major grade in science class for second quarter. So now that we've kind of gone over that, let's go ahead and open up Tuesday, January 19th folder. We have a bell ringer. We have a PowerPoint, and we have an activity, a practice activity. So this PowerPoint goes along with the notes that were posted in last Friday's folder. So if you want to fill in the guided portion of these notes, you have access to the PowerPoint here. The notes that you will be typing in and submitting are found in last week's Friday's folder. So I'll show you where that is so you have it. So if you go back to second quarter, this week right here, Friday, January 15th, you will see endothermic and exothermic guided notes. When you click on it, there is a Google Docs, and you can type in your answers there. And this corresponds to the PowerPoint we're going over today. The same PowerPoint's embedded here, but this was supposed to be independent work activity assigned for Friday. So if you didn't do it then, you can do it now. So now that I've shown you where that is, I am going to go through direct instruction on the PowerPoint just to make sure that anybody that has any questions or concerns can get that addressed. So give me just a moment, and I'm going to pull up my PowerPoint so that you guys can see that. And the name of this PowerPoint is Rate of Chemical Reaction. So basically reviewing and going over the factors that we've been discussing now for a couple weeks and how those factors do in fact impact or can impact the rate of a reaction. So there are four main things we're going to be talking about and focusing on today and in the review activity. All right, so the rate of a reaction is how quickly or slowly it happens, how rapidly it's going to take place. And in terms of reactions, there is something called the activation energy, and this is the amount of energy required for a reaction to take place. So some require higher amounts of activation energy than others. So how can we modify or change, reactions? Well, we can modify four things. And this is the focus of the review activity we're going to do in the packet that you guys are going to kind of be working on. Temperature, concentration, surface area, and the presence of a catalyst or inhibitor. So let's start with temperature. If you increase the temperature, you see an increase in the rate of a reaction. So the warmer something is, the faster it's going to happen. And this is because particles actually move faster and bump into each other more. The more the reactants or particles bump into each other, the more likely they are to form products. Some examples of this are when energy is added to solids, they become a liquid. So think about ice. If you have an ice cube, it's a solid. Water in a solid form. Add energy, it turns into a liquid and begins the process of melting. And that's because the particles that make up water molecules themselves start to move around more quickly when you add energy. What about liquids to gases? Well, in the process of boiling, you put the pot on the stove, water molecules are moving, but they're not moving as fast as gas molecules, and you add energy to it, they speed up faster, 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 move around more, and you form a gas. So when energy is added to a system, particles are going to move around. They become energized, they bounce around, they move really fast, they bump into each other. So the reaction rate increases. When you take energy away, they slow down. So for example, think about a freezer. right? You put water in a freezer, the water molecules stop moving, they lose energy, they slow down, slow down, slow down, slow down, and eventually you form a solid called ice. So you can affect the rate of a reaction based on the temperature, and that's why we keep food in the refrigerator. They last longer because we slow down the rate of chemical reactions like decomposition. Now let's take a look at this diagram here because this diagram kind of encompasses everything. So what happens when you add energy? So adding energy is displayed here in the top. So if you look at the center, it shows you ice. This is water. Red is oxygen, and the little white circles are hydrogen. This is ice. Notice that ice is in a uniform structure. Water, the uniform structure breaks down, and the particles are probably touching and moving a little bit more. Then look at water vapor. Well, these are all still the same molecules, but they're spread out and they're moving much faster. So if you add energy and you go from a solid to a liquid, you're melting, particles moving faster. If you increase the energy even more, liquids eventually undergo evaporation and become a gas. So all of this at the top represents what we call endothermic processes adding energy. On the opposite end, what happens when you release or take away exothermic or energy exiting the system? Well, you can start out with water vapor, and as energy leaves, the particles cool down, temperature decreases, and they start moving around less. So this is called condensation, going from a gas to a liquid. If you continue to lose energy or exothermic processes continue, water loses even more energy and eventually undergoes freezing and becomes a solid. So again, cooling a reaction down, exothermic, taking away energy can cause particles to slow down and decrease reaction rate. What about concentration? This is our second way we can affect the rate of a reaction. The more particles present, the more reactant that's present, the faster it's going to happen. So the more solute that's dissolved, the more particles there are to collide. So if you increase the concentration, you increase the reaction rate. Surface area, this is the third thing, and this seems where students typically have the most issues. So if you increase the surface area, you increase the chance of collision taking place. So surface area basically represents how much area of a individual particle there is to come into contact. So the more sides or the more pieces of something there are, the higher the surface area will be. And the more surface area, the faster reaction occurs. So look at the example at the bottom of sugar. Both of these are sugar, and both of these represent the same mass. However, the cubes will take longer to dissolve because they have less surface area. They're in bigger pieces. Compare that to the granulated sugar on the other side where the spoon is pouring it out. Those are in little bitty tiny pieces, a whole bunch of them. So they have a higher surface area and the reaction will take place more quickly. You guys can think about dissolving. Obviously, this is going to take longer to dissolve in your tea than granulated fine sugar. Another way to change the reaction rate is through the addition of a catalyst. So a catalyst is some type of substance that initiates or accelerates a chemical reaction without it being affected. So a catalyst works by lowering the activation energy. In biological organisms, catalysts are typically referred to as enzymes. So they make things happen faster and more efficiently. So for example, salivary amylase is an enzyme found in your saliva, right? The spit in your mouth, if we're going to use layman's terms, right? So saliva helps break down food, not only moistens food, but it also begins the process of breaking things down because there is an enzyme present. So it starts to speed up the reaction of, well, digestion, even in your mouth when you're chewing. What about an inhibitor? An inhibitor is the opposite of a catalyst. So an inhibitor is going to stop or decrease or slow down a reaction rate. So it's a substance that slows down or stops a chemical reaction. It inhibits the process from happening. So now that we've talked about those four factors, temperature, concentration, surface area, and catalyst, those are the four big things that affect reactions. Now let's do one more quick review on the difference between endo and exothermic. So remember, endothermic processes, energy is going to be absorbed. Energy is going to be absorbed or taken in. Endo means to go in. When an endothermic process happens, the external environment will start to feel colder. So think about an ice cube in your hand. As you hold an ice cube, The ice cube itself is absorbing thermal energy, an endothermic process, from your hand. So the surrounding tissue of your hand starts to feel cold because it's taking away thermal or heat energy. What about exothermic? This is where energy is being released or removed or given off. So exo means to go out and the surrounding environment feels hotter. So exiting or giving off. So combustion reactions, for example, are exothermic processes. So now that we've gone through this review, if you were in class last Friday, you should have already completed these and filled in the guided notes. If you were not, that was your independent assignment for last Friday. And last Friday was January 15th. So on January 15th, you should have went through this PowerPoint and completed the Google Docs guided notes. If you didn't do that, here's your chance to go back and do it now. So back into Tuesday's folder, we did go over a bell ringer. And so the bell ringer talked about endothermic versus exothermic reactions. And there was an image here. And basically in this image, it's showing you endo versus exo. So your job should have been to explain that in an endothermic reaction shown here with the ice cube, thermal energy or heat is going into, and that results in things like melting. On the other example, it was exothermic. So in exothermic, heat or energy is leaving the system, so going outward. And an example of that is combustion reactions, right? Burning. And you guys know that if you've ever stood near a fire or burnt some wood or something, you can feel the heat or thermal energy coming off. Now, the next activity for you today is what we call rate of reaction. So this goes over factors that affect the rate of the reaction. Down here at the bottom, I have your PDF attachment. When you open up the PDF, when you click on it, it's going to open up into a document. The PDF has 2 pages of reading assignment, and then the rest of it is part of this lesson. So, today's today's recording is going to include Tuesday and Wednesday. So on Tuesday in class, we started this activity and did the first 2 pages. Wednesday in class, we're finishing or completing this. This activity is going to act as the review for your test. So again, this activity will act as your review. So this PDF corresponds to the worksheet that is going to be given to you on Tuesday, January 19th. We'll go over that, and on Wednesday, January 20th. So this acts as practice and a study guide activity. So your job before you begin the work is to read through the assignment. It's only 2 pages. Then you need to work through the questions. Now, the questions are broken into 2 sections in Google Docs. So page 1 and 2, which is this portion right here, different rates of reactions, part 1, and the fill in the blank is what was assigned to you on Tuesday. So once you've done that, you've read through that, you will click on the Google Docs, and this is where you are going to submit your answers. Now, in the Google Docs, I also have the reading assignment. I just also included the PDF so you guys could have both. So when you scroll down, this is where you will complete the vocabulary. You will use these terms to fill in the blank. And then you will indicate whether each of the following would increase or decrease the rate of reaction. So your job as the student is to work through this first on your own. Then come back to the video and I will go back over it so that you have the correct answers for your study guide, okay? But your job first is to test your knowledge. Practice completing these, then go back or come back to this video, and at the end, I will go over the correct responses for this assignment. You will need to submit this for a grade. Okay, so that is it for Tuesday, January 19th. And since the assignments build together, I'm going to go ahead and progress into Wednesday's folder. So Wednesday, January 20th, we have a here, Rate of chemical reaction. So this is a continuation of the study guide assignment you started in class on Tuesday. And then we're going to watch a video for brain pop and go through a practice quiz. We do have a bell ringer today, but the bell ringer asks you which would burn faster, a large log or a pile of twigs. Explain your reasoning and use essential vocabulary. So think about this and make your response. Which one would burn faster and why? Use your vocabulary terms. Think about the 4 factors we discussed. How does it relate to this particular question? And I will come back to this because this question actually relates to something we have in our study guide review activity. So after you answered your bell ringer, you're going to go to rate of chemical reactions. We started this activity. This is the same PDF that you should have viewed on Tuesday, January 19th. This is the second portion of that assignment included in this Google Doc. So again, here's the PDF, but this is where you're going to type your responses. So when you open it up, this is how it's going to look. This corresponds to the sheet, okay? So you have the instructions, and this is where you are going to type your responses, all right? So there's this section here, and you're going to scroll down. Now, this one right here, it says the graph above. Use the graph to answer the question. The graph that corresponds to this question is embedded in the PDF that I showed you guys earlier in the week. So the PDF for this assignment is in Schoology. So here's that PDF. Again, I attached it at the bottom of the page. So when you go to answer this one, this is the corresponding graph. So you will use this graph to answer that question in the Google Docs assignment. So that graph corresponds to this right here. So after you complete that portion, you'll move on to this section right here, and then the last portion of the assignment. So you are basically working through this packet. So your job now in the assignment is to work through these portions on your own, to practice and assess your knowledge. Once you have finished that, come back to the video and I will go over and review the correct responses with you. Once you have gone back and listened to the review of the assignment with me, then you can post it for a grade. This packet, along with the first portion you did on Tuesday, acts as your study guide in preparation for your exam on Thursday, January 21st. So please work on that section now, practice, and then come back to the video so that you can check your work. So at this point, what I'm going to do with everyone is I'm going to work through and go over the assignment with you. Everyone should have done the first portion of this assignment. So I'm going to display the PDF that goes along with it. Again, your work is included in a Google Docs, or if you were in class with me the first half of the week, you have a physical copy. So let's take a look and work through these responses and check your answers. The first page is relatively simple because all you're doing is you are practicing your work, practicing your key. So to check your work on the first page, and this first page, so this portion we're checking now corresponds to the assignment that you should have done on Tuesday, January 19th. So go back to that document and check your work. Number 1, a freshly exposed surface of metallic sodium tarnishes almost instantly if exposed to air and moisture, while iron slowly turn to rust under the same conditions. This situation is known as the rate of reaction, and it refers to how quickly or slowly reactants turn into products. So rate of reaction for number 1. Number 2, adding heat will increase the rate of reaction because this causes the particles of the reactants to move more quickly, resulting in more collisions and more energy. Number 3, Removing heat will lower the temperature, causing the particles of the reactants to slow down, resulting in less frequent collisions. Number 4, concentration refers to how much solute is dissolved in a solution. If there is a greater concentration of reactants particles present, there is a greater chance that collisions among them will occur. More collisions mean a higher rate of reaction. Number 5, a concentrated acid solution will react more quickly than a dilute acid solution because there are more molecules present, increasing the chance of collisions. Number 6, grains of sugar have a greater surface area than a solid cube of sugar of the same mass, and therefore will dissolve quicker. So the greater surface area, the faster things will dissolve. Number 7, a catalyst, for example, is an enzyme used to speed up a chemical reaction, but is not used up in the reaction itself. And number 8, lastly, is a part of a car called the catalytic converter. Down here, number 8 is catalytic converter, and this was actually added to all cars starting in the 1970s to kind of reduce emissions. Now that we've gone through this one, let's kind of keep on scrolling down. So now we're going to go over different rates of reactions, this second one here. Again, this portion of the assignment was part of Tuesday's work, so January 19th Google Docs assignment. So let's go and review. You should be checking your answer. So letter A, adding heat increases the rate of the reaction. B, removing heat decreases the rate. Letter C, adding a catalyst increases. D, diluting a solution decreases the rate. E, removing an enzyme decreases the rate. F, lowering the temperature decreases. G, increasing the temperature increases. H, decreasing the surface area decreases. I, increasing the concentration increases. And J, breaking a reactant into smaller pieces will increase the rate of the reaction. So again, your job here was to think about all these scenarios and how it would either increase or decrease what will happen. So now that we've gone over those two sections, that is it for the assignment that you submitted on Tuesday's January 19th. The remaining portion of this assignment was completed on Wednesday, January 20th. So I broke the assignment into two separate parts. Now, as we work through these scenarios, you should again be checking your answer. And once you've checked it, you can submit your work. Identify which situation would have a higher reaction rate. Then state the factor. There were 4 factors we discussed, so you're checking your work here. So the first column, and you can see that continues all the way down to situation X. The second column, the situation Y. And then you're going to tell me which one has a higher reaction rate and what factor was included. So if you go back to your notes that was included, the assignment that you're typing in, you should see that. So let me go back up here. So this is where you should pick up, okay? So I didn't include the images here, but this basically corresponds to the activity. So you can see here, these two correspond to one another. So we're on part 2 here. So you should be typing in your answers here and checking your work. Okay, so letter A, 1 gram of sugar versus 1 gram of granulated sugar. Well, which one is going to react faster? Situation Y, and that is because of the factor known as surface area. So Y has higher surface area. So the higher the surface area, higher the reaction rate. So this should be Y and surface area. What about option B? we have two temperature scenarios, 50 degrees Celsius and 0 degrees Celsius. So for this scenario, the response would be situation X. So this situation here with the beaker, 50 degrees Celsius, is going to have a higher reaction rate, and that is because of the factor known as temperature. Letter C, comparing the number of particles. Low number of particles equals fewer collisions. High number of particles equals more collisions. So if you have a higher concentration, higher particles, you're going to have a faster rate. So here, faster rate would be scenario Y, which is this one right here. And the reason for this, so Y would go in this column. Again, you're typing yours here. So the situation would be Y because it has more collisions. And factors that affect the rate of reaction is known as concentration. Now let's look at scenario D, and I'm just going to show the Google Docs for right now. Situation X, enzyme. Situation Y, no enzyme. Well, which one is going to happen first? Situation X. So situation X will go here. And that is because of what we call a catalyst. So catalyst would go in this blank here. Twigs versus logs, and this was the bell ringer for Wednesday. Well, twigs are going to burn faster. So situation X, and that is because of surface area. So that is the completion of that portion of the assignment. So now let's check the work that corresponds here. And so that I can go over the graph with you guys, I'm going to go back to the PDF that corresponds to this, and we're going to take a look. So in this graph, it tells you the graph above shows the differences in the rate of reaction for different temperatures, concentration, surface area, and the presence or absence of a catalyst. So the steeper this line right here, the greater the rate of reaction. So let's check our work. So anything associated with this line, which is X, means it's speeding up. Anything associated with Y means it's slowing down. So let's take a look. Well, lower temperature, that would definitely be Y. I'll go ahead and type this in here so we can work through it. Higher temperature would be X, because it's going to be faster. Lower concentration would be graph Y. Higher concentration, graph X. Absence of a catalyst, graph Y. Presence of a catalyst, graph X. What about surface area? Well, if it's a small surface area with larger pieces, that's going to be the slower one of graph Y. Smaller pieces, meaning a large surface area, would be graph X, which happens more quickly. Okay, so here's your responses here. And again, they correspond to this graph right here. So anything that makes it faster is graph X, and anything that makes the reaction slower is graph Y. All right, so now that you have those filled in, and I'm just going to erase these because otherwise it's going to save these to my document, and I'll mess up on my settings. Now let's take a look at the last section here. On this page, number 2, which of the factors affect the rate is most important in each of the examples or scenarios? Well, let's take a look. So what you guys are going to do for this portion right here is you're going to highlight it. So if you think it's concentration, highlight in yellow. If you think it's red, if you think that it has to do with temperature, highlight it in red. If it's surface area, highlight it in blue. If it's catalyst, highlight it in green. So I'm just going to kind of go through this with you guys. So remember that raw carrots cut into slices. Well, if you're cutting into slices, that's going to be surface area. Section B, protein is broken down in the stomach by an enzyme. That would be catalyst. B, a woolly mammoth is found perfectly preserved. Well, that's temperature. And then the last one, D, more bubbles appear with a concentrated acid solution than with dilute acid. So that would be concentration. So D should be yellow. C is temperature. So C should be in red. B is a catalyst. So B should be green. and surface area should be blue for letter A. So let's move on to this last portion here. And again, I'm going to go back to the PDF so you guys can kind of take a look. Here we are with the last page of the assignment. This portion right here is matching the descriptor with the name. You guys should be able to do this. You have all the notes that you need. We have gone over this, but this is good practice. You should be able to correctly match the term with your descriptor. So what does that look like in your Google Docs? Well, you're just going to pick the description and type the letter here. So whatever you think the correct response should be, you're going to fill that in. Go ahead and make sure those are done, match those now, but this is something you guys at this point should be able to do on your own without any help. But you should have 1 as D, 2 as C, 3 as A, 4 as B, 5 as E, and 6 as F. So now let's move down to number 7, 8, 9, and 10. So what I want you guys to do is make sure you've highlighted this. And again, this assignment should already be done. You should have taken time to do this on your own. We are now checking our work. So for number 7, when you walk through a crowded hallway at school, you are more likely to bump into another person. So which of the following factors would affect this? Catalyst, temperature, surface area, concentration. Well, this would be D, concentration. That's what you should have highlighted. The more people there are, the more to bump into. Number 8, which of the following are true about temperature and how it affects the rate? Well, number 1, heating causes the particles of reactants to move more quickly. That's true, it does. Number 2, lowering the temperature will raise the energy level. Well, lowering temperature doesn't do anything but slow them down. What about number 3? Increasing the temperature results in more collisions between particles. That is true. So for this one, scenario 1 and scenario 3 are correct. So this answer is in fact B. You should have B highlighted. Number 9. Increasing which of the following will increase the frequency of collisions? Temperature, surface area, concentration. Well, all 3 of those will affect the rate. So this one is 1, 2, and 3. So your correct response is D. Lastly, number 10, which of the following will lower the rate of reaction? Let's go through this. So again, which one is going to lower it? That's what you're focusing on. Adding an enzyme? No. Enzymes speed up rates of reaction. Remember, enzymes are biological catalysts. Decreasing the temperature. Well, that's definitely going to do it, but just to make sure we're clear, let's check the other remarks. C, breaking a chunk of calcium into smaller pieces. Well, if you break it up, you're increasing surface area, which means it'll dissolve faster. So C will actually happen faster. Letter D, increase the amount of solute dissolved in a solution. Well, that relates to concentration. So if you're going to increase the amount, it's going to dissolve faster. So the best response and correct response for this would be letter B. Okay, now that we have gone through this and we've discussed, you should have your correct responses. You need to go ahead and submit now. Please remember that this page, part 2, was assigned on Wednesday, January 20th. Part 1 was assigned on Tuesday, January 19th. I just went over both portions and correct responses. Make sure those are updated and submitted. These 2 pages act as your study guide for your test on January 21st, which is this Thursday. Please make sure you are reviewing and prepping. So now that I'm done with that, I'm going to go ahead and close these out. And I'm going to go ahead and close out this document because we've already gone over it. We've reviewed pages 1 and 2. So now I'm going to come back to Wednesday's Schoology folder. So the last assignment that I have for you guys is a chemical bonds brain pop practice quiz. I'm going to play the video here on the recording so you can watch it. Then you will go in and you will do the practice quiz. I will be uploading the correct responses to this quiz this afternoon to your Schoology page. So regardless if you're in 4th period, if you're in 1st, 3rd, 4th, 5th, or 6th, this afternoon I will upload the correct responses so that you can go back and check your work. Okay, So after you watch the video, your job is to respond, and you're going to click on the boxes here. Remember, if you need to zoom in, you can do this. It's probably too big, but if you would like to zoom in, you can do that. Maybe just do 100%. There you go. That's a little better. So you will click in the boxes to do your response. Then you will submit this for a practice. Make sure you go back and take a look at the correct responses that I'm going to be posting in Schoology so that you can check your work. So now that I've gone over that and how you're going to submit, this is the last thing you're doing for Wednesday. Okay, so in Wednesday's folder, this is your last assignment. And let me go back so you can see that. So you've done your bell ringer. We've already gone over this. We've discussed the correct responsive. I've explained that you need to submit it. This is the last portion here. After you watch the video, do the practice quiz and submit for a grade. So now let me get my Brain Pop video pulled up, and I will show that video for you guys now. The link is embedded in Schoology. However, if there's a problem with the link, this way, you guys can still see the assignment, or you can still watch the quiz. So give me just a moment, and I'm going to show that to you now. So let me change my sharing so you can see the video.
All done? Dear Tim and Moby, how do hydrogen and oxygen stick together to make water? Atomic glue or something? From Tabitha. Actually, she's not that far off. Atoms do tend to stick together, almost as if they were glued. If they didn't, there wouldn't be any visible stuff. Just a bunch of microscopic atoms floating around by themselves. Whoa. But atoms like to stick together, and the reason has to do with what's inside them. Atoms are made up of three basic particles: positively charged protons, negatively charged electrons, and neutrons, which have no charge. Protons and neutrons clump together in the center of an atom, forming its nucleus. Electrons whiz around the nucleus at different distances, which we call shells. Oh, shells aren't really perfect circles. This is just a simple model. In reality, electrons orbit the nucleus in three-dimensional patterns called clouds. But the circular model helps us see that each shell can hold a certain number of electrons. The first shell, closest to the nucleus, can hold 2. The second shell can hold 8 electrons, while the third shell can hold up to 18, and so on. And this is where things get sticky. Sticky. The number of electrons in an atom's outermost shell control how reactive or likely to bond it is. When the outer shell is completely full, the atom is inert, meaning it will resist bonding.
Get lost.
8 electrons is another stable pattern, even in shells that can hold way more. In all of the noble gases, the outer shell is either full or has 8 electrons. That's why they almost never form bonds. The other elements on the table tend to occur in molecules, sets of 2 or more atoms bonded together. It helps to think of atoms as wanting to be inert, so they try to gain or lose electrons to reach a stable number. Well, take water. It's made of 2 hydrogen atoms and 1 oxygen atom. As you can see, hydrogen has 1 electron in its outermost shell. It would love to have 1 more, since 2 electrons would fill that shell up. Oxygen has 6 electrons in its outer shell. Since the second shell can hold 8 electrons,
Oxygen is looking for 2 more. So, oxygen shares a pair of electrons with one hydrogen and another pair of electrons with another hydrogen. Now all 3 atoms are stable.
Yay! Yay!
This sharing of electron pairs is called a covalent bond. Nope, that's not the only way atoms stick together. Ionic bonds happen when one atom takes an electron from another.
Yoinkers!
The extra electron gives the first atom a negative charge, and the other atom becomes positively charged since it lost an electron. In other words, they both become ions, atoms with electrical charges. And since opposite charges attract, they bond together. This is called electrostatic attraction. Sodium chloride, which is just table salt, is held together by ionic bonds. That's a good point. On their own, sodium and chlorine atoms have totally different properties than salt. Sodium is a soft metal that burns the skin and explodes on contact with water. And chlorine is a poisonous green gas. But when these two elements react, they form an ionic bond, and we get an edible crystal. Yep, covalent bonds can change an atom's properties too.
Hydrogen and oxygen are both invisible gases, and hydrogen is explosive.
But when they react, they form water, a very stable liquid.
If you break that covalent bond with a little electricity, you get hydrogen and oxygen gas again.
No, wait! You know, every week it's the same thing. I teach you something cool, you shoot a laser beam out your finger, and I get in trouble. Well, not this time. I'm gonna pretend I didn't hear that.
All right, so hopefully you guys watched that video and found that to be a good review. And once you have finished that, remember your job, I'm going to show you one more time, is to go back into Schoology, today's folder. And in that folder, since you have reviews, so remember today, this video kind of included both Tuesday and Wednesday of this week. So Wednesday, January 20th, I'm going to share one more time. Here we are. So after you have watched the video, let me change my settings, you guys. After you have watched the video, you guys need to make sure that you go back and you complete the assignment.